tonight we try to talk about nanotechnology. I do understand everybody here actually knows about nanotechnology, yeah, because nanotechnology is very certain knowledge here in 2 or 3 decades. Yeah. Before that, let me show you something. Yeah. This is kind of nanomaterials. Yeah. We call nanocrystal cellulose, isolated from empty fruit bunch of palm oil from Indonesia, and I produce these materials, very little amount of materials for 3 months.
Apa namanya?
Nanocrystal cellulose.
Jangan dimakan, Pak.
Yeah. It's very fine.
Kenapa ada markus dalam?
Very fine materials. Yeah. We call as nanomaterials if physically has dimension, yeah, of size about 100 meters, 100 nanometers or less. So let's say, just imagine this is a kind of materials. We call nanomaterials if these materials have the length, yeah, from 0.1 to 100 nanometers, and the size of diameters less than 100 nanometers. So very small amount actually, and of course we cannot see by naked eyes. Yeah. So every single crystal here consists of millions of nanomaterials. Yeah. Again, so everybody can see it. Sometimes they say how fine the nanomaterials. If we have like hair in our heads, yeah, we divide it about 100,000 scale, so we can imagine how small the materials. Yeah. The important question is actually why everybody want to use nanomaterials. What the motivation? What's the main motivation to do that? To use these materials? Yeah. First, how to provide very small materials. Let's say if today we can buy, let's say, like hard disk, very small amount hard disk like this, but containing 100, even 1 tera gigabytes inside the memory. Yeah. Another one. Another one, how to get a very light material in the future. So later, when we have, is it like laptop today or notebook, in the future, you're gonna have just only very slim one, even is it like a piece of paper, maybe, yeah, because of the nanomaterials inside. And another one, very sensitive materials. Yeah. For example, if we have like this is my finger. With the finger with micro size. Yeah. So when we align them, this finger, we can see some void inside. But compared to nanomaterials, when we align them, there is no void at all. Nggak ada celah. Yeah. So that's why the device, yeah, will be very high sensitive. Yeah. So today they provide biosensor from nanomaterials as well. Yeah. Another one, this material is very high cohesivity, yeah, each other, yeah. So very good mechanical properties. So that's why even today they provide some materials for mechanical purpose, yeah, by using nanomaterials. Just as a comparison, yeah. That's nanomaterials. Yeah. We can arrange molecule level. Yeah. And look at this. Even smaller than virus. Yeah. Smaller than bacterium. So that's why today they prepare antimicrobial membrane, yeah, without any disinfectant agent inside. Yeah, just use these materials and how to block the bacteria or virus. Yeah, without any chemicals adding inside anymore. So again, why we use nanoparticles? Yeah. So the first answer is very high surface area. Yeah. Very high aspect ratio. And of course, in results, we reduce the material size. And as I said, the reactivity is very good. And for coating is very, very easy to adjust. Yeah? I'm going to show you how to prepare so far. Yeah? In fabrication process, so far maybe later they're going to have another one, but until today they have three type of nanofabrication process. Yeah? By synthesis, by self-assembly, and by patterning materials. I know that is very, very basic, very technical terminology for you maybe. And this is the cluster, yeah, the cluster of nanomaterials we have until today. Yeah, hopefully later we're gonna extend this list, yeah. Yeah, how to profile it, yeah. So far again, yeah, we can profile by top-down process and bottom-up and ultimate goal. Yeah, it's bottom-up, yeah, and top-down, the opposite. Yeah, it's top-down, like this, from the bigger one, how to make it smaller, much smaller. Okay. And this is one of the example how to make it, yeah, in photo lithography. Yeah. Yeah, that's the what is it, another. Oh, sorry. Yeah, this is another way how to profile the nano materials. Yeah. Yeah. bottom-up molecular self-assembly like what I did just now. Yeah, to isolate the nanocrystal from cellulose, plant cellulose. Yeah, and this is inorganic, kind of inorganic nanomaterials. Yeah, and very famous in nanotechnology. Yeah. And then, yeah, that's important thing what I show you actually. This is plants, yeah, with the micro size of the cell, yeah. And then we try to methylation to have this, and finally we can isolate nano materials. Yeah. We can see from here why the nanomaterials have very strong mechanical properties, because they have a lot of heterogeneous bonding inside. Yeah, compared to microsized cellulose, it is just only a couple of hydrogen bonding. Compared to this, a lot of heterobonding inside. So that's the reason why we isolate the nanomaterials from plant cellulose. So I think it's enough just to actually give you introduction about nanomaterials for tonight, and I invite you to have some useful discussion for this topic. And thank you so much.